Okay, so let me begin. This is not your first time anyway to encounter functions. You had a discussion of functions in your algebra and then in your advanced algebra 2 and last semester with me in calculus 1. So just to revisit or to review your previous knowledge about functions, here are different graphs. There are in fact 1, 2, 3, 4 graphs shown on your screen. Now I'd like you to identify which among the 4 represent a function. Which among the 4 represent a function? Okay, let me check on your responses. Okay, what about this? The third graph. The third graph. This is such a peculiar graph, right? But you encountered this last semester with me. Can you recall? This is a special type of function. How do we call this function once again? Looks like a staircase, right? This one, I'm referring to the third graph. That with several parts. And it looks like a staircase. There are several steps in the graph. There are several parts of the graph. Greatest integer function. You're right, Jerry. Okay? So, this is a function. You're right. What about the fourth one? Look at the fourth one. We did this too in calculus 1. What about this? Can you recall? You're right. The third is your greatest integer function. Looks like a ladder, right? And then the fourth one. First of all, is this a function? Is the fourth one a function? Correct. Signum function. Okay. Best in recitation, Jerry. Signum function. Grace 2 said signum function. So, graphs number 1, number 3, and number 4 are functions, but not the third. Okay? But not the second rather, but not the second. Let's move on to the next. Now, we proceed to reviewing the definition of a function. Okay? So, we define the function this way. We are talking of two non-empty sets. Let x and y be non-empty sets. A function f from x to y, denoted as f, where f is a mapping between the elements of x to y, is a matching or a correspondence or assignment of each element of x to exactly one element of y. Okay? We write it as f of x is equal to y. Or if y is the unique element of y assigned by the function f to the x element of x. And we call again the first set of all x's, or the set of all first elements, as the domain, and the set of y, or the set of all second elements, as the range. So your function can be defined as a relation. It can also be defined as a relation, or you know what a relation is? A collection or a set of ordered pairs. But we have to include, yes, the condition that no two ordered pairs should have the same first coordinate. Okay? No two ordered pairs have the same first coordinate. So, given a function f, which is a mapping from x to y, we say f, the function, maps x to y, or f is a mapping from x to y. Or we can represent it using the diagram. As you can see from your screen here, x is an element of set x, y is an element of set y. When the function f acts upon x, it brings it into the element or into y. So x, which is an element of set x, is acted upon by the function and brings it into y. The function acts upon x and bring it to y. Y is equal to f of x. So like what I said earlier, x is called the domain of f, while y is the codomain or the range. Or sometimes we even encounter the words such as image and pre-image. Y is called the image and x is the pre-image. Okay? Next, a function given, the mapping is given here. Here is an example of a function. Okay? This is an example of a function and it is presented in the form of a mapping. Now, let's answer the questions regarding the given function. Okay, number 1. Like what we did in the previous meeting, you can respond via chat. Okay, so number 1. What is f of negative 1? Refer to the diagram. F of negative 1 is, okay, correct, negative 1. Number 2. What is the image of 2? Image of 2 is 1. Correct. So, you're right. Next, what is the domain of f? Negative 2, negative 1, 0, 1, 2. Okay. The set of all x values. Correct. What is the codomain of f? Negative 2, negative 1, 0, 1. Next, number 5. What is the pre-image of 1? What's the pre-image of 1? Pre-image of 1 are, okay, all of you responded 1, 2. Now we move on to the next. So there are several ways by which a function could be presented. The first slide, if you could remember, I showed graphs. Okay? So a function could be presented in the form of a graph. The second way, mapping or arrow diagram. Okay? So a function can also be presented in the form of an arrow diagram, just like what we have here on your screen. This is an example of an arrow diagram. Okay, showing your domain, each element of the domain mapped to, okay, a specific element in the range. For instance, the first figure would show negative 1 is mapped to 3, negative 2 is mapped to 7, negative 3 is mapped to 9. Now, looking into the second mapping. Look into the second mapping. 1 is mapped to 3. 2, however, is mapped to 7 and 9. What can you say about the second mapping? The second mapping, does it represent a function? No. Okay, correct, Jerry. This is not a function as 2 is mapped to 7 and 9. Remember from our description, or should I say from our previous slide, it's a set of relation, or should I say set of ordered pairs, such that no two ordered pairs have the same first element. Because from the arrow diagram, in fact, we could come up with, yes, ordered pairs. So for instance, in the first arrow diagram, we could come up with the set consisting of 3 ordered pairs. And the ordered pairs are 1, 3, 2, 7, and 3, 9. For the second mapping, what ordered pairs can we form out of it? 1, 3, 2, 7, and 2, 9. Looking into the second mapping, the ordered pairs that we could get from there are 1, 2, 1, 2, 2, 3, 2, 7, and 2, 9. So this came from our second arrow diagram. So 1, 2, 2, 7, and 2, 9. Previous mapping, 1, 3, 2, 7, and 3, 9. Yes, so the first mapping, you could come up with the set of ordered pairs 1, 3, 2, 7, and 3, 9. And in the third mapping, now let's look into the third mapping. The third mapping, we have 1, 3, 1, 3, 2, 7, and 3, 7. Okay. So we got this from our, so all of these were obtained from the mappings. Which among the mappings, or should I say the set of ordered pairs, is a function? We said that number 1, oh sorry, this is the previous, yes, baligtad kasi ang sequence niya. This is a function. This is also a function, but not the first, okay? But not the first set of ordered pairs. What makes the first set of ordered pairs not a function? Looking into the first elements, what did we say? A function is a relation such that no two ordered pairs have the same first coordinate. I would like you to specially look into 2, 7, and 2, 9. So their first elements are the same. So clearly, this is not a function. So let's proceed. Go back to our PowerPoint presentation. Are there questions at this point? Okay, now may we continue. Again, a function could be presented in the form of a graph. You know this very well. And you know your vertical line test. Yes, the vertical line test can be used to determine whether the graph is of a function or not. So, the first graph, we draw the vertical line along this side. Then the vertical line would cut the graph into points. Therefore, this graph is not of a function. What about the second? If I draw the vertical line along this side, okay, along this side, then it will touch the graph at one point only. Okay? So if we draw the vertical line anywhere in the graph, and it passes through the function at most one point, then that is of a, or it passes through the graph rather, through the graph at most one point, then that graph is of a function. Now, we proceed to types of functions. The first type of function is called injections. Okay? Injections or injective functions. A function is said to be one-to-one. Okay? If and only if for all A and B in the domain, for all, take note of that. For all A and B in the domain, f of A is equal to f of B if and only if A is equal to B. Okay? A function is said to be injection, or if it is one-to-one. So, when is it an injection? If the function is one-to-one. Now, let's look into the arrow diagrams. Look into the first arrow diagram. 1 is mapped to D, 2 is mapped to B, 3 is mapped to A. 1 is to 1. Okay, 1 is to 1. This is a one-to-one mapping. It's a one-to-one correspondence between the sets of X, elements of X rather, and the elements of Y. So this is an example of an injection. How about the second? In like manner, in the second mapping or arrow diagram, 1 is mapped to D, 2 is mapped to B, 3 is mapped to C, 4 is mapped to A. Therefore, this is a one-to-one function. So it's an injection. But looking into the third arrow diagram, 1 is mapped to D, 2 is mapped to B, 3 is mapped to C, and at the same time 4 also is mapped to C. So there are 2 values in X, there are 2 elements of X having the same Y value, and those are 3 and 4. And therefore, this does not qualify the third arrow diagram to be an injection. Okay? It's not an injection. So, no. It's not an injection. So, remember, when is a function an injection? If it is 1-to-1. Now, to test whether a given function is in injection or not, if the graph is given, a horizontal line test can determine whether a function is injective or not. The horizontal line must cut the graph at one point only, or once. Okay, let's look into an example. Show that f of x is equal to 3x minus 2. Or should I say, show that the function f of x equals 3x minus 2 is an injection. Okay. So how do we prove that the function 3x minus 2 is an injection? There are 2 ways. This is the graph. Okay, this is by graphing. This part of the screen shows the proof by graphing. So you can graph the function given y is equal to 3x minus 2. By the way, what type of function is it? F of x is equal to 3x minus 2. What kind of function is the function f of x is equal to 3x minus 2? It's, linear function. It's a linear function. Okay, so f of x is equal to 3x minus 2. You know for a fact that this is a linear function. Now going back. So here is the solution. Now remember from the definition that there should be no 2 values of the domain that will yield the same y. Now if we go back to our arrow diagram, y is the third arrow diagram, not an injection, because there are 2 values of x that yield the same y value, and that is c. Okay, there are 2 values of x that yield the same y value, or there are 2 x values being mapped to c. Therefore, this is not a 1-to-1 function. It's not an injection. So applying that concept here, how do we prove whether the function given is an injection? We have to show that f of x sub 1 is equal to f of x sub 2 only when x sub 1 is equal to x sub 2. Okay? Only when x sub 1 is equal to x sub 2. So how shall we do that? We simply have to replace x sub 1 and with, or should I say, replace x with x sub 1 left and right. Okay? So our function is, this is what we are going to show. X sub 1 is equal to x sub 2. X sub 1 is equal to x sub 2. So we simply replace x sub 1 with x here with x sub 1. So 3 times x sub 1 minus 2 equals 3 times x sub 2 minus 2. Okay, from your addition property of equality, if we add 2 on both sides, then this will become 0. So what is left? 3 x sub 1 is equal to 3 x sub 2. And again, from your multiplication property of equality, if we multiply on both sides 1/3, then this will be reduced to x sub 1 is equal to x sub 2. Okay? So we were able to show that x sub 1 is equal to x sub 2. Or, ask yourself, okay, for instance, if I would ask you what f of 1 is, okay, go back to the function given. What is f of 1? Okay, what is f of 1? F of 1 will be what? 2. 1. Yes? So, 3 times 1 minus 2. This is what we call evaluating a function. So, let's evaluate the function or finding the value of the function when x is 1. F of 1 is equal to 1. Now, let me ask you, is there any other number aside from 1 which when substituted or taken as the value of x will yield 1 as the function value? Is there any other number aside from 1 which when taken as x value will also give us a value of 1? 0. Pwede? If this is 0, 3 times 0, 0 minus 2, negative 2. If negative 1, 3 times negative 1 is negative 3, minus 2 is negative 5. So, none. Okay? So, this is justified. X sub 1 equal to x sub 2. Or, we can only arrive at 2 equal function values when x values are equal. There is no other x value that will give this answer. Okay, let's have another one. What about f of, let's say, 3? F of 3, what will that be? F of 3 is 3 times 3 minus 2. And what is it equal to? Okay, 7. So, this is the function value when x is 3. The function value is 7 rather, when x is 3. Question, is there another x value that will yield 7 as the function value aside from 3? No more. Okay, so that's one test also. Okay, that's also one test of, or one way of checking whether a given function is an inversion or not. Or sorry, injection rather. Injection or not. So it's not. Okay, so this is an example of a one-to-one or an injection. We proceed to the next. Okay, look into the examples. Other examples to help you understand further what injection is. Okay, you see this now? Okay, number 1. Can you see this? The first function, f, is a mapping between the elements of the set of real numbers to the set of real numbers. Okay? R mapped to R. If there are questions, you can just feel free to type your questions in the chat box so we can address your questions before we proceed to the next slide. A function which maps the set of real numbers to itself. And the function given is x squared. Okay, what kind of function is this? What kind of function is f of x equal to x squared? Quadratic. Okay, yung kanina, it's a linear function and it's one-to-one. Okay, this is a one-to-one function. Now, your quadratic function, f of x is equal to x squared. So, this one must be an injection. Now, how about the function f of x is equal to x squared? Remember that you can use a counterexample to disprove. Okay, to disprove. But several examples, even 1,000 examples, 1,000 specific cases, hindi enough yun to support a claim. But when you disprove, one counterexample is enough. So how will you disprove that this is not rather your quadratic function f of x is equal to x squared is not 1-to-1. Remember from our previous example, we looked into f of 1 and f of 3. And I kept asking you, is there any other number in x? Or is there any other x value that will yield the same function value? And you said none. So let me ask you now, for f of x equal to x squared, if I would ask you what is f of 2? F of 2 is 2 squared or 4. But, what is f of negative 2? But what is f of negative 2? Also 4. So, there are two x values that yield the same function value. And these are negative 2 and positive 2. Both positive 2 and negative 2 give a function value of 4. Therefore, is y equal to x squared, or is f of x equal to x squared 1-to-1? Is it 1-to-1? No. Okay? So, no. Why? Because there are two different values of x that give the same function value. Not only negative 2 and negative 2 and positive 2, also with 1 and negative 1, right? 1 and negative 1. Okay? 3 and negative 3. Okay, so the first is not an injection. So it's not 1-to-1. Now we move on to the next. Number 2. 2 is similar to our previous example because this one is also a linear function. F is a function defined in the set of real numbers where f of x is equal to 3x. Again, like what we did in the previous, we have to show that f of x sub 1 is equal to f of x sub 2 only when or whenever x sub 1 is equal to x sub 2. Okay, just like what we did in the previous. 3x sub 1 is equal to 3x sub 1, and then cancelling out 3 on both sides, we were able to show that x sub 1 is equal to x sub 2, meaning, okay, no two function or no two values of x will give the same function value. No two different x values will give the same function value. Questions here? Now, let's go back to my previous example. To the first example prior to the two exercise problems. Let's go back to this. Okay? The linear function has this graph. Okay? This is the graph of the linear function. Okay? If we have a vertical line test for testing functions, there is also what we call a horizontal line test. Correct. Pag quadratic, hindi na siya injective kasi there will be two x values that would give the same y value. You're right. Now, going back, this is the graph of the function f of x is equal to 3x minus 2. Apply the... Yes, all linear functions are injection. Now, this will answer your question, Freddy, because all linear functions would have a graph which look like this, either slanting to the left, slanting to the right, yes? So if we draw the horizontal line at any point along the graph, it will intersect or cut the graph once only. And therefore, yan, hence it is injective. So the horizontal line cuts the graph at one and only one point. Hence, it is injective. Okay, so that answers your question, Freddy. Okay? Because all linear functions would have a line graph. Okay? A graph which looks like this. Either slanting to the left or slanting to the right. Now, you might be asking me, how about a horizontal line, ma'am? A horizontal line is not a linear function. Remember? That is a constant function. Okay? Is a constant function. But linear functions may have a graph which slant to the left or slant to the right. And then by using your horizontal line test, okay, you can say right away that it is injective. Questions at this point? So I answered the question of Freddy already. Now we continue. Other questions on injective? So injective, 1 to 1. When is it 1 to 1? When there are no two values of x that will yield, okay, that will yield the same function value. So you have to keep that in mind. As simple as that. Now we move on to surjection. Surjection naman. What about a surjection? So the first is injection, the second is surjection. A function f from x to y is called onto. You see, the English word onto and into have different meanings in mathematics. The first is into, x into y, and then this surjection is x unto y. A function f from x to y is called onto if and only if for every element of y, every element, okay, every element in the range is paired to an element in x. I take note. This may be very technical, but let me make it simple. It's as simple as this. If every element in y, every element of y is mapped to an element of x with f of x equal to y, then the function is called a surjection. Okay? And it is unto x unto y. In other words, if the range, remember range, set of all y values, and the codomain of a function are equal, the function is onto or surjective. Now, let's look into the examples. Number 1. Okay, number 1. The first, I erase my board first so that you could easily grasp the concept or the meaning of a surjection. If the range is equal to the codomain. What do we mean by this? Okay, let's look into our mapping. In the first mapping for x and y, 1 is mapped to D. 2 is mapped to B. 3 is mapped to A. Nothing is mapped to C. Can you see that? Nothing is mapped to C. Whereas in the second arrow diagram, we have the x elements are 1, 2, 3, 4, and the y elements are D, B, C, A. 1 map to D, 2 map to B, 3 map to C, 4 map to A. And then we have letter, the third one, which is X, Y, 1, 2, 3, 4, map to D, B, C. Look into the first arrow diagram. What are the elements of X? 1, 2, 3. Look, 1 is mapped to D, 2 is mapped to B, 3 is mapped to A. What do you notice about Y? Okay? What do you notice about the Y elements? There is one element of Y. There is one element of Y which is not mapped to which is not mapped to any x element. But take note, it's part of the codomain. Okay? C is part of the codomain. Okay? There is one element of y left. Meaning, surjection if in every element of x there is a corresponding element of y. Yes. Is corresponding element of y? Lahat naman may corresponding element. Okay? The question is there a y value? Is there a y value which is not mapped to any x value? There is. Okay? C. Okay? There is a value. There is an element of the codomain which is not mapped to any x element. Therefore, it did not satisfy this. The range, if I would ask you, what is the range of this function? You would say, the range of the function is the set consisting of D, B, and A. Agree? You would say, the range of the function is the set consisting of D, B, A. Compare. Is this the codomain? Is the range the same as the codomain? Is the range the same as the codomain? No. Okay, clearly, the codomain and the range are not equal. Therefore, this is not a surjection. Did you understand? Okay, this is not a surjection. C is not mapped to any element in X. So the codomain and the range are different. There is one element of the codomain which is not part of the range, and that is C. I hope that is clear. Now, how about the second arrow diagram? In the second arrow diagram, yan, 1 map to D, 2B, 3C, 4A. What is the range of this arrow diagram or of this function? The range is D, B, C, A. And if I would ask you, what is the codomain? It's also D, B, C, A. Therefore, is the second arrow diagram surjection? Is the second arrow diagram? Yes. Okay, next. Let's proceed to the third. Okay? Our domain are 1, 2, or the domain rather, consists of the elements 1, 2, 3, 4. And what's the range of the third? D, B, C. Okay, D, B, C. Question. Is the range of this the same as its codomain? Is the range the same as its codomain? Yes. Okay. Therefore, it is also a surjection. Okay? It's also a surjection. Is that clear? Clear? Okay. Now, we proceed to the next. Ayan. Sabi nga dito, it says here, take note that in the first mapping, although C is an element of Y, yan, C is an element of Y, it is not part of the range of the function. So when we speak also of range and codomain, there is a difference between the two. And also, we have to be very careful in using the terms codomain and range. Okay? Range and the codomain are not the same for in the case of the first arrow diagram, or the first mapping rather. The first mapping is not a surjection. C is a part of the codomain. However, it is not part of the range. Okay? Because the range is only A, B, D, and it does not include C. So, obviously, second mapping, the range is D, B, C, A, and at the same time, that's the codomain. In the third mapping, the range of the function is D, B, C, and at the same time, it's the codomain. Okay? Next. Questions at this point? None so far. We move on to exercises. Okay. Example number 1. Show that, this is again from our previous example. The same function, I made use of the same function. 3x minus 2 for the set of real numbers is surjective. What about the set of integers? Looking at the function y is equal to 3x minus 2. Shift to the board. Okay? The given is y equal to 3x minus 2. How shall we show whether this is a surjection or not? Now, there are two parts in the problem. Letter A, let's look into the function R map to R. This is our domain and codomain. Okay? Let me write. Let this be our domain, codomain. Domain and the codomain. What are we going to show? That the codomain and the range are equal. How shall we show that? We have to solve for x in terms of y. Solve for x in terms of y. And y plus 2 is equal to 3x. And then if we divide both sides by 3, then y plus 2 over 3 is equal to x. Now, for the first part of the problem, yan siya. Checking for this. Assign y values and solve for x. Check whether the results are real numbers. So, for the purpose of uniform answers, may we look at y equal to 0. If y is equal to 0, then what will x be? If y is equal to 0, what will x be? 0 plus 2 over 3 is 2 over 3. So, 2 over 3. Next, if y is 1, what will x be? Okay, 1 plus 2, 3 over 3 is 1. X will be equal to 1. Okay, the resulting x values are R, elements of R, yes? Set of real numbers. Therefore, we say that it is surjective. Okay? It is surjective. Because, okay, if I take any real number for x, or if I pick out any real number as my x value here, will the result be also a real number for y? Will the result be a real number too? Yes, real number. So, F map R map to R. It is surjective. What if the function is defined on the... What about when the domain is the set of integers? Okay? This is how we denote the set of integers, z to z. Okay, so your domain is the set of integers and your codomain is the set of integers too. Yan. Second part. Let the function be defined on the set of integers. Okay, let the function be defined on the set of integers. Looking at this, let's separate it from the first so that you won't get confused. Dito na tayo. Sa pangalawa tayo. The first is a surjection. Okay? It is surjective. But what about the second? Looking at this. If y is equal to 0, we said a while ago that x should be becomes 2 over 3. 0 is a member of the set of integers. Yes? In your x, what can you say about x? Which is 2/3. integer? Is it an integer? 2 over 3? See that? Okay, that's it. 2 over 3 is not an integer. Okay? Although if y is equal to 1, you'll end up with x equal to 1. Okay, this is an integer. But there are y values. Okay, there are y values that will yield a non-integer. For instance, 0. Okay, a while ago, r positive to r positive. How about r to r? Is it also surjection? Let's check. Let's check. If x is equal to 1, what will y be? Y will be 1. If x is equal to 0, what will y be? 0. But if x is equal to negative 2, what will y be? 2. If x is equal to negative 3, what will y be? Positive 3. Question. R includes the negative numbers, right? Remember, R includes the negative. Question. Will there ever be an x value that will give you a negative real number? Will there ever be an x value? So, these are all r greater than equal to 0. Ito r buo. Okay? R in the codomain includes the negatives. But if this is the function, you will never ever get a negative answer. And therefore, is your range the same as the codomain? Is the range, look at your range, 0 to positive, correct? Your range is only 0 to positive. However, your codomain is all real numbers. And so, is this a surjection? Is this a surjection? Not a surjection. Okay? So be very careful with this. Look into the codomain and compare it to the range. So you always have to compare the codomain and the range. So I hope that is clear. Okay, is that clear now? This is not a surjection. Okay, look at exercises. Look at the exercises, particularly number 2 in relation to this. I think related to this. See, number 2. Is the function f of x equal to x squared from the set of integers to itself on 2? Okay, function this time is x squared. Okay, the function is x squared. And the function is defined set of integers to itself, z to z. Z map to z. Integer unto itself. Set of integer unto itself. Okay, let's answer. Although answer is already in the slide, but let's discuss it further. Ito, dito sa ano ko muna. Okay, so, your function f of x is equal to x squared. Z to z, give me a z value, x equal to 1. What will y be? 1. Yes? If x is equal to negative 1, what will y be? 1. If x is equal to negative 2, what will y be? What will y be? If x is negative 2, what will y be? 4. If x is equal to 2, what will y be? 4. Oh, look. Compare the range. Look at your range. Range. Okay? Your range and compare it to the codomain. Compare the range and the codomain. What can you say? What can you say about the range and the codomain? Are they the same? What does it include? Z. Z includes your negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and so on. Your range here would be 0, 1. Okay, 0, 1. Not even 2. You can never have 2. you will never arrive at 2. So 1, 4, 9, and so on and so forth. Compare it to your z. And your z includes negative 2, negative 1, 0, 1, 2. Obviously, comparing the codomain and the range, are they the same? Are they equal? No. So, it's not a surjection. So, I hope everything is clear about surjection at this point. Now, may we proceed to the next. The last for this afternoon is bijection. Okay? So, bijection is when the function is both 1-to-1 and onto. Okay? If it is 1-to-1 and at the same time, yan. A bijection is both injective and surjective. Anong sabi natin sa injective? 1-to-1. And surjective? Surjective if the range and the codomain are equal. So, if the function satisfies this, okay, it is 1-to-1 and at the same time onto, then it is a bijection. Now, let's look into the first arrow, first mapping. Okay, is it 1-to-1? Yes. Is it a surjection? Yes. Therefore, is it a bijection? Yes. Okay? Next. Okay, no problem. Papasa ko sa inyo tong PowerPoint. Next. How about here? Is it 1-to-1? Is it 1-to-1? No. 3 and 4 are both mapped to C. So, definitely, this is no longer a bijection. Okay, exercises. Yan. Looking into this mapping. Okay, looking into this mapping. Is F injective? Is it 1-to-1? A mapped to 3 only. B mapped to 0. Are you sure? Ayan, no? B and D are mapped to 0. Okay, no, it's not injective. Is it bijective? Is it bijective? No, because it is not injective. Okay? How about this? Okay? Is it 1-to-1? Is it injective? Yes, 1-to-1 siya. But, is it surjective? Surjective? No, because there is one member of the codomain which is not part of the range, and that is Antarctica. And therefore, obviously, what's the answer to the third question? Is it bijective? It's not bijective. Okay? Next. Okay. Second to the last slide. How about this? Is this injective? Is this injective? Ana, map to geometry, Minda, stat, Marla, physics, Miriam, history. And at the same time, Miriam, map to biology. Oh, sa letter C nga, what can you say about letter C? I want to look at your responses for letter C. I want to see your answers. Correct, very good. The first to say it's not a function, very good, Maribeth Domingo. So, you do not proceed to answering the questions anymore. Because in the first place, it is not a function. Like what Cleto said, Miriam, yan, Miriam is being mapped to biology and history. So, it disqualifies the diagram, or should I say the arrow diagram, to be a function. And the last, is this injective? Yes. Is it surjective? Yes. Is it bijective? Yes. All yes. Okay? Because it is both injective and surjective. Any questions at this point? Okay. So if there are no questions, then I leave you with your assignment and to be passed next meeting. Okay? handwritten or encoded, whichever is most convenient to use. So there are 3 types of functions. Once again, they are injection, subjection, surjection rather, and bijection. Are there questions at this point? None so far. Okay, so that's it for this morning. Thank you very much. Thank you. Bye everyone. See you next